Alright, 15, 16, 17, 18, 19. We're gonna go with one color whole video, no switching it up. Name of this compound, C3H8. So these are your hydrocarbons. So you start with methane, ethane, ethane, propane, butane, methane, propane, butane, and so each one of these counts for the number of carbons. So this will have carbon, C2, C3, C4, then you go pent, and it goes on from there using your prefixes. So pent, hex, hept, oct, none, and decane. This would be C10. But if you know the number of carbons and you recognize that it's only carbon and hydrogen, you'll know it's a hydrocarbon. So in this case, 3 of them, and propane. So 15 should be C, and it is. Which of the following pairs are incorrect? So carbon disulfide, di, so it has to be 2 nonmetals, non-metal, di, there's 2. Beautiful. Dinitrogen trioxide, 2 nitrogens, 3 oxygens. That's between 2 nonmetals. So we have our prefixes. Yep. Sodium thiosulfate. So sodium is Na, plus thiosulfate is actually S2O2, I think, or S2O3. It's one of the two. But S2O3, that's right, and it's 2 minus. So basically what happens is you have sulfate, SO4 2 minus, and another sulfur atom comes in and takes the place of one of these oxygens. So it turns into S2O3 2 minus. So we have the correct number of sodiums here, but we have the incorrect half right here, right? It should be this. It should be Na2S2O3. So that one can't be it. Or that one is it. That can't be right. And carbonic acid, that's correct. So C for 16. Alright, 17. Epsom salt. Magnesium sulfate. So Mg2 plus sulfate. We just did. SO4 2 minus. Put them together, and what do you get? MgSO4. Now, there's a heptahydrate. This is where you have to know your prefixes. Hepta. And hydrate just means that there's water attached to it. So this would be magnesium sulfate heptahydrate. Let's see what we got. Nope. It has 2 magnesiums. Nope. Not enough water. Nope. That's magnesium sulfite heptahydrate. That's magnesium sulfate monohydrate. Oh, right there. E. Same thing I got. Alright. Next one. Which of the following pairs are correct? Sulfurous acid. I ate it. It was ick. But it was just right for us, right? Sulfurous. And so that would be SO3 2 minus, and that's the sulfite ion. So yes, sulfurous acid. Correct. Nitrogen, right? So nitrogen's one of the diatomic. It's just going to be called nitrogen. And so we have H2N2O2 F2B Cl2 Br2 and I2. Those are all of them. So yeah, nitrogen's correct. Chromic acid. So chromic means we're dealing with chromate, which is CrO4 2-. So what do we got here? This would be dichromic acid. So that's your answer. And this is no name. No name's correct. And obviously not all of them are correct. After combustion analysis of a molecule, you find the empirical formula to be CH2O and the molecular weight to be 180.15768 grams per mole. So we'll stop right there because we need to find how many grams of the molecule we have. In order to do that, we need to know, you know what? There's a shortcut here. If you have 2.27 moles and the molecular weight is this, there was supposed to be another way to do it, but let's do it the way you can do it the easy way. You have 2.27 mole of the molecule with the empirical formula of that. And by the way, it's C6H12O6. This is what the actual molecule is, but if you know the molecular weight, which I don't know why I did this, then you can just do this. Moles times 180.5768 grams per mole, and you should get A, right? Let's see, 180.15768 times 2.27. Yep. 408.957. Now I went another way about this when I solved it. So see how close we are again? Oh wait, never mind. 3 sig figs from right here. So 409 grams. That's how many we have. So A.